All right, here we are on the third video for this topic, solving equations containing rational expressions. And you might notice that I haven't really been teaching you anything new. Problem after problem after problem, they are the same technique. It's just practice. So allows you to have a lot of practice solving because you're going to need that. All right, so we have to factor this denominator, and that's going to be x minus 3 times x minus 4. Remember, I told you on a previous question that the other two denominators sometimes will give you a clue, and in this case it's true that those are the factors. And then let's rewrite this so we can solve. First, we're going to clear the denominators. Okay. So we multiply through by the LCD. In this case, that's going to be x minus 3 times x minus 4. And then remember those excluded values that we've been talking about that cannot be solutions, and that would be 3 or 4, because those are the two values for x that would make our denominator 0. Now we're going to multiply all three expressions by our LCD. And then that will eliminate our denominators. All right, so the whole thing is gone on the first expression. And then just the x minus 3, which leaves us 3 times x minus 4, so that's 3x minus 12. We're going to eliminate x minus 4, so that's going to be 5x minus 15. Okay, so then we have some simplifying to do. We want everything on one side equal to 0. Let me go ahead and combine like terms. Okay, so we're going to subtract the 8x. We're going to add 27. And then this is the trinomial that we'll be factoring. So I'm going to rewrite it here. Oh, I think I can write it right here. So this one factors of 7 that have a sum of -8. Well, 7 only factors. In this case, you know, it's 1 times 7 or -1 times -7. So we need -1 times -7. So x minus 1 times x minus 7. Because when I add -1 and -7, I get -8. Okay. And then we set those equal to 0, those two factors, and then solve for x. So 1 and 7 are our two solutions, and that's it, because of course you can go back and check the 1 and the 7 in your original equation, but neither of those are excluded values, so that is good for this one. All right, so we have one more. First, we factor this difference of squares, and that will be the common denominator. All right, so I don't know what's happening here. Oh my. All right, so I'm going to pause and fix this. I'll be right back. Okay, so I was trying to write this out. Sometimes I have to get out of my app and back in to be able to get it to function properly. So, all right, because my two factors are x minus 3 times x plus 3, my excluded values will be -3 and +3. So those are the two values that cannot be a solution. And then, of course, my LCD will be x minus 3 times x plus 3. All right, so we go through this process of rewriting. And leave some space. Whoops, Maybe I scoot that closer to the plus sign. If only I could write. Then we multiply every expression in our equation times our LCD. Okay, so this will eliminate the first denominator completely, and we don't have to multiply by anything, right? Of course, it is going to eliminate all the denominators, the 2. And then on the next one, we're multiplying 1 times x squared minus 3 times x plus x squared. Okay, x minus 3 times x plus 3. I'll get this straight in a second. And I'm thinking ahead because I'm going to multiply this out. That's really x squared minus 9, right? And I'm multiplying that times 1. That's what it was initially before I factored it. And then on this term on the other side of the equal sign, it's going to be 2x times x minus 3. So 2x squared minus 6x. All right, so in this case, I'm going to put everything on the right-hand side, and that's because I want my leading coefficient to remain a positive number. And that is important here because it just gets confusing when you're trying to factor otherwise. So I'm going to subtract the x squared. I'm going to subtract the 27. So it's x squared minus 6x minus 27. And then I'm going to factor, right, factors of 27 that have a sum of -6 would be -9 and +3. I'm going to set those equal to 0. And solve. So x equals 9 or -3. And you can see the x is not equal, cannot be equal to -3 or +3. So we have to exclude, right? This is one of my excluded values, and that means x is 9, right? That is my one solution that is going to be okay in this case. And then that's it for this example and for this lesson. All right.